Good evening, and aloha from all of us here at the Hokulani Imaginarium in Kaneohe, Hawaii. Since our planetarium theater has been closed since March, we thought we'd find a way so you can enjoy some mini planetarium sessions at home instead. Now, however, looking at the sky on a computer screen is quite a bit different from seeing the sky in our planetarium, or especially from looking up at the night sky yourself. So, I'd like to take a couple minutes to help you get more familiar with this sort of view. We're starting off getting ready to watch the sun set in the west. It is July 1st, and the time is around 5:30 in the evening. Because this is a virtual planetarium, I'm going to use our superpowers to speed up time and help the sun set faster. Here, in this view, the sun is above the big tree on the screen right. You probably also see a bright object in the sky on the screen left. That's the moon. For a few days before and after the full moon, of course, you can see the moon for a few hours during the day. In our virtual view here, we've also made it a bit bigger and brighter than reality, so it's easier to see in this video. Actual sunset today, that is the time when the sun finishes going down below the horizon, is at 7:17 p.m. The technical definition of sunset is the time when the last visible part of the sun, the top of the disk, the circle, goes below the true horizon. Now, I say the true horizon because it may not be the same as it looks for us here on the surface of Earth. You may remember that light can be bent or refracted when it has to travel through many layers of air. It's the same effect that makes the stars twinkle or makes a mirage in hot weather. Now that the sun is down, it is twilight, the time between sunset and a truly dark sky. These are the times when you'll start seeing lots of stars. We'll begin by turning to face south, like we do in the planetarium. I will also make sure that we have letters on the horizon to mark the compass points, the cardinal points, north, south, east, and west, and the semi-cardinal points, southeast, southwest, northwest, and northeast. In these videos, you may see more shooting stars than you will see on an average day outside. We do that partly because we control the sky here and want to make it a little more interesting to watch. And partly that's because some of those moving objects are not actually shooting stars or meteors at all, but they are satellites. Sometimes when a satellite or a space station or a spacecraft passes overhead, it catches the sun and reflects it in a way that even after sunset, we can see it very brightly as it moves. That'll be an idea for a future video. We can talk all about how to look for satellites. The view here on a flat screen is also going to be different than what you'd see outside or inside our planetarium. Think about if you just pointed a camera at the sky. Usually, you'll only be able to capture a small rectangle of it at once. You'd always have to be moving around in order to see a large area. Or you can use a wide-angle lens. That's sort of what we're doing here. We've set up a very wide field of view in our software, enough that we can in fact see one entire half of the sky at once. You've probably already noticed that we can see all the way from the east in the left Past south in front of us, over to the west on our right, that's 180 degrees of horizon. And we can also see from the horizon ahead of us on the flat ground up to 90 degrees directly over our heads. I've turned on what we call an altitude azimuth grid. That's a grid of lines with some lines parallel to the horizon, marking every 10 degrees of altitude from 0 at the horizon up to 90 exactly overhead, and vertical lines that mark every 10 degrees of azimuth or bearing. And as we turn around, you would be able to count 36 of those, making 36 degrees in a whole circle. Where those lines converge overhead at the 90-degree point is what we call the zenith. That's the point that'll be directly over your head, whether we're facing north or south. You'll always be able to see a star on that point on our screen, no matter what direction we face. You'll also notice that even though these lines should be just 10 degrees apart, and they'll be 10-degree squares, some of those are narrower and some are wider. That's because of this fisheye distortion that comes along with a wide-angle lens. Now I'm going to speed up time, and we can watch as the stars pass overnight and wait until the sun rises again. Thanks for watching this virtual video with us. We hope you'll come back for more of our planetarium shorts in the future. Until then, aloha and good night.